So I'm recording here, but I'm kind of, yeah, I'm going to move into section 5.6. So I'm adding a 5.6, which is called integration by parts. So IBP, we call it integration by parts. So we're going to start that in a second, but let's do one more problem from section 5.5. So this is a 5.5 level 10 example. So I've got the integral of x minus 3 over x squared plus 2x plus 5. And you can see it's the same downstairs as before, just to save us a little bit of time right now. But on your test, it'll be different. Is my screen clear? My video seems to be lagging on this side, but okay. Every now and then the screen will go really fuzzy, and you just have to tell me. And then I need to restart, and it's a memory issue on my side. So if you ever, it's like pulling a fire alarm when you're in high school. So if you ever want to just have a break, you can just say, Robert, your screen's really fuzzy. And then I'll say, okay, I'll be right back. So this one I would say to you, the directions I would write on this is divide and conquer and complete the square. And again, I tend to not leave the process decision up to you. I will tell you what you're doing to be able to solve it, because it's hard enough just to solve the problem once you know how to start. Anything I can do to try and make a very difficult class a little bit easier in this remote environment, I'm trying to do. It doesn't mean I'm just going to ask you easy problems, right? That's boring. You won't enjoy it. You want a challenging exam. You want to walk out of here or stand up out of the test and go, yes, I'm the best. That's what you want, that feeling. So I can clearly see that this is a downstairs. So before I even got to level 10, I saw that there was a downstairs here, right? See you later. Good luck. So once I recognize that there's a downstairs piece, I want to go through that process. Now, it says divide and conquer, complete the square, but this is Robert. I know it's Robert telling me these are things I'm going to have to do in the problem. Maybe not first, right? So du is 2x plus 2 dx. And notice how I have that grouped there, because that whole piece is that derivative, right? It would be wrong for me to write 2x plus 2 dx, right? You see the difference there? I've got to be saying that this whole thing is my dx. So I don't have a 2x upstairs, but I can make it happen. Can I? I can make it happen. So I can multiply upstairs by 2 and divide by 2. So now upstairs I have 2x minus 6 over x squared plus 2x plus 5. How are we doing here? No problem, right? Everybody's comfortable with this so far. Nice, Rhonda. Thank you. So, but what do I want upstairs? I want 2x plus 2, right? So this is where I'm going to add 0, right? So I'm going to borrow a 2 from the negative 6, right? So I have 2x plus 2 minus 8 over x squared plus 2x plus 5. So we had in that level 3 part add 0, right? So you can see here it looks like I added 2, but really I added nothing. And now I'm ready to divide and conquer. Now that I've got what I needed for my u, I can divide and conquer. How are we doing here? Nice tonight. Eleanor's you're there too. That's great. Chuck, you okay? Yep. So I've got 1/2 of the integral of 2x plus 2 over x squared plus 2x plus 5 dx minus 4 times 1 over x squared plus 2x plus 5 dx. Right, the 1/2 and the -8 canceled there to the -4. So there's my divide and conquer. Split up my numerator into the piece I want and the leftover piece. Right, both over the denominator. It's like undoing common denominators, undoing adding fractions. Well, the first piece is a 1 over u du. So that's 1/2 of the ln of the absolute value of x squared plus 2. Right? I mean, I can go put in that u sub if I want. Right? But we've done a bunch of those already. Right? It's a 1 over u. I know that's an ln. Notice I don't really need the absolute value there. Like if I graphed that quadratic, I would see that it opens up and is the vertex in above the x-axis. So I don't need that absolute value, but I'll deal with that a little bit later. And then the other one, I'm going to complete the square on, which we already did, right? It was x plus 1 quantity squared plus 4. So the other one, I'm going to see that arctan piece. How are we here? So by the way, this problem comes from an application problem in chapter 6. So that's what's going to happen. We're learning all of these integration methods in chapter 5. We learn how to learn what these things are related in the physical world, or geometric world is where I'm more focused. And so a problem in chapter 6 where I'll say find the area between two curves will turn into a problem where you have to do divide and conquer, complete the square, that type of thing. So I know I have to factor out a 4 here, right? So I'm going to factor out a 4 from this downstairs, right? Which is just like dividing here by 4. So I have the ln of the square root of x squared plus 2x plus 5 minus 1 over 1 plus x plus 1 all over 2 quantity squared dx. And so I already did this problem before, right? So I know I need a 1/2 dx, right? I need a 1/2 dx, so I got to cancel it with a 2. And so now I'm ready for my final answer here. I've got the ln of the square root of x squared plus 2x plus 5 minus 2 times the arctan of x plus 1 all over 2, all plus a constant c. And that one problem took 9 minutes for me to do, nice and slow. I think I give you about 16 to 20 minutes per problem on the exams. So, but you're going to be practicing, you'll get faster. The key is to go as fast as you can where you're not making mistakes, right? And then when you do make a mistake, it's often hard to see the mistakes. So I would say look at something and see if you can see a quick mistake. If you can't, try the problem over completely, right? So you have plenty of time to do the problem twice, in my opinion, as you practice. What do you think? Tonight's got the scream face. It's nice to be pushed in terms of difficulty, right? I got to tell you, this class is not easy. I think DiffEqs is challenging. Calc 3 is very easy. I think linear is very easy. You will have a lot of proofs in linear, so you definitely want to look into that Shaw's outline, advanced linear. Discrete structures should not be difficult. It will be brand new. It will be brand new to you, but it shouldn't be difficult. What else? That's it, right? That's all we're going to. And then, of course, the math major is Josh. Is it Josh, math major? Who's a math major? Charlie, maybe? You're going to do advanced calculus. That's proving all of the things we did in calculus. Right? Those are tough classes. Advanced Calc 1, Advanced Calc 2. 300 level classes. One's 300, one's 400, I think. All right, let's do some new stuff. This is fun and this is easy, and we have that often in the class. We'll do something very difficult. We'll do something new. It's very simple, and et cetera, et cetera. It'll keep bouncing like that, right? And so you just got to practice. That's it. You got to practice. And one of the reasons why. Go ahead, Josh.
Yeah, I had a quick question. How did you get to 8 around the first step?
How did I get the 8? Oh yeah, so I know I need a 2x plus 2, right? So I kind of borrowed a positive 2 from the negative 6. It doesn't make a lot of sense. It would have been easier for me to write this. 2x minus 6 plus 2 minus 2. There's me adding 0. That's a little bit easier to deal with. So now I could rearrange that as 2x plus 2. That's what I needed. And then I still have a minus 8 left over. That would have been a better way for me to explain it.
Okay, thank you.
Yep. All right, so here we go. Integration by parts. So integration by parts actually works often. It's kind of another version of a U-sub, but because we have these methods that I've given you, 1 through 10, that are easier than integration by parts, we'd rather you try those methods first before you jump right to integration by parts. If there's a clear inside, done, right? So, but sometimes these methods won't work, and then we're trying a level 11 now, integration by parts. I'm going to stop saying level numbers because I'm going to call this integration by parts from now on. And on your exam, I'll say solve this integral using integration by parts. Okay. So first of all, what is the formula that we want to memorize? And I will prove it to you today as well. So the integral of u dv is uv minus the integral of v du. So this is going on our formula sheet. So I'm looking for, so obviously you see a u sub here, right? See a u sub, right? And so we have a process of how we pick our variable u. And that is with our Lyautey list. And it almost sounds like I'm having a cup of coffee, but I don't like milk, so I'm not going to order a Lyautey. I'm just going to give me a cup of coffee. And so this is my choice for u in order. So my first choice would be L, which is a logarithm. I, inverse trig. A, algebraic polynomials. Okay. T, trig, and E, exponentials. So my first choice would be a log, an inverse trig, algebraic, polynomials, okay, a trig, and then an exponential. So this is my choice of u in order. Once I find u, everything that's left over is dv, right? So once I pick out u, I know the piece that's left over is my dv. And if you can see, I'm going to need to find u, I'm going to find v, and I'm going to find du. So basically, I have to find u, find the derivative du, find dv, find the integral v, right? Find du, see dv, and find v, right? So once you pick u, it's easy to find du. And then once you pick u, it's easy to see the leftovers dv, and then integrate to find v. How we doing? Process pretty clear so far? Let's do a nice simple problem. And you'll see when I'm teaching this, I've got about 4 things to do. We just do a couple of problems. We do problems with what I call a loop, where the problem repeats on itself, and then you have to solve for it. And then something called tic-tac-toe, a shortcut version of it, and then I want to prove the whole thing. Okay. So that's the rest of our class today. I think I can get it done. I think I can get it all done. I wouldn't mind you reading this section in the book. Okay. My math majors, I would like you to be okay with the proof, so make sure you can write it over on your own. That's Charlie and Josh, right? Josh, remind me, please. If I'm getting it wrong, I'm sorry. I'll look. I need you to do my job for me. I'll do my job. Oops, don't share that screen. Sorry. Have trouble. Okay, so let's do one of my favorite problems to ever do, and that is the integral of the ln of x dx. Now, I haven't done any definite integrals, right? Right? What's the difference between an indefinite integral and a definite integral? I haven't done any definite integrals yet, so please do the ones in MindTap for 5.5. So the indefinite integral is where I'm just finding the antiderivative, right? The definite integral is where I'm finding the area under the curve, okay? So make sure you're doing and reviewing some of those definite integrals. Like the one we did the other day would have been a good one to do with a definite integral, right? Sorry, I'm off track, I know, but like from 0 to pi of sine 2x dx should equal 2 times the integral from 0 to pi of sine of x cos of x dx, right? So make sure you're doing some of those definite integrals. I had asked you to show that those two were the same by using a trig sub, right? But you certainly could show that two are the same by picking bounds of the integral and showing the areas are equal. Anyway, let's go back to this one. What's my first choice for u? Well, my Lyapunov list says log. Do you have a log function here? ln of x, right? That's that easy. Look for those things in order. Okay. What's du?
1 over x.
Nice, 1 over x dx, right? We want to keep that that thought process of those differentials involved, right? Everything else is dv. So dv is dx, sorry. Right? So dv is dx. That's the only thing left over in my integral there, and you can really see that if I integrate both sides here, I get v equals the integral of dx. That's really what I want, right? Which is just x. And in this case, we don't bother with the plus c yet. Okay, we don't bother with that constant of integration at this point. Okay. So I've got everything I need. Is everybody comfortable here? Okay, great. Eleanor, thank you. David, yes. Sarana, yes. Eru's nice. Adam. Nice. Haoshin. Okay, so I got everything I need. I'm ready to plug into my formula, right? The integral of dx is going to be uv minus the integral of v du. And of course, I've got that written on my formula sheet, right? I would say to my students, listen, if you're going to get a tattoo, if you're going to dedicate yourself to the integration by parts formula and get a tattoo, I don't think that's cheating. I think that's real dedication. Now, I'm not saying you've got a formula sheet. Don't get the tattoo, okay? People have asked me if I got a mathematical tattoo, what would it be? I said a decimal point.
Professor?
Yes.
Actually, could you explain again the integral of dv equals the integral of dx?
Yes. So we had this idea of once I find u, right? So I've got ln of x dx. This part is u. Everything that's left over has got to be dv. So dv is dx, right? Everything left over is dv. So then when I integrate that, on the left side I get a v, and on the right side I get x, right? So remember, it's a 1 dv, so the antiderivative of 1 is a v, and it's a 1 dx, so the antiderivative of 1 is an x, right? And remember, we're integrating using those differentials. So on the left side, you're integrating in terms of v. On the right side, you're integrating in terms of x.
Okay, thank you.
Does that make sense, Ash?
It makes a bit more sense.
Okay. You'll see every time it's just whatever's left over. And I really could just say, v is everything left over, right? Because there's an integral and a dx left over. I can really just go there. It's probably more proper for me to do that. More proper. I don't know if more proper is proper, but you know what I mean. All right, so u is ln of x and v is x. So x ln of x minus the integral of v, which is x, and du is 1 over x dx. So I'm just taking all of these pieces and plugging them in, right? I'm just taking all my pieces that I've created. And with those 4 pieces, I should be able to get everything. So now I have the integral of ln of x dx is x ln of x minus, well, x and x cancel, minus the integral of dx, which is just x again. So x ln of x minus x. Plus c. We wait for that plus c all the way at the end there, right? We're doing that integration by parts. It has another integral inside, so we wait for that integral to give us the constant we need in terms of the shift. There it is, your first integration by parts. I don't think this particular aspect is difficult, and it's very powerful, very, very powerful. So we'll try another. So let's do x sine of x sine of x. We'll keep it nice and simple at first. Okay, nice and simple at first. So from my Lyautey list, what is my value of u?
Sin x?
Yep. I'm sorry? Sin x? So LIA is algebraic, right? So u is x, right? And that means find du, and then v is the integral of sine x dx. On your mark and set, go. I'll be right back. Oops, sorry. Du is dx, right? How we do? Anyone get there? Two classes in a row with a perfect attendance. Very, very proud of you. Let's keep
Robert?
keep that going. Yes.
Minus x cosine x plus sine x plus c.
I got Chuck. Can you see my screen?
Yeah, I did. I got the same thing.
Oh yeah. Yes. Thank you. Good work. Go ahead tonight.
Do you mind explaining Lyautey for me, please, one more time?
Sure. So where does it come from? The math gods. I didn't come up with it. So, but it's giving me a list of the types of functions that are best suited for u, the u sub. So if I see a log, that's my first choice. So in this particular problem, the first thing I saw was x. So there's my algebraic coming before the trig. So my first choice is u is x.
Okay.
If I only saw a trig, then my choice would be the trig, right? So I'm looking for what comes first in that list to be my u sub, and then everything else is dv.
Right.
I know it's strange. You haven't seen it before. It's kind of difficult to trust, right? It's difficult to trust. I mean, I'm going to prove the theorem, but where does this Lyautey list come from? It's just hundreds of years of people doing integrals and realizing that if you have a log, to integrate the log, if I have a log function and I take a derivative, that's easy. But if I have a log and I have to take an antiderivative of it, it's not easy. So that's why we're putting these things in this order, just from trial and error. Anybody else get there? Charlie? Yes, nice. Melky? Yes? Michael, you got there?
Yes.
Nice. Michael got there? Nice. Adam, Charlene, nice.
Okay, Professor, when you do this problem, I understand that it's the integral of u, the derivative of v equals u times v minus the integral of v du.
Yes.
So why is it the integral cosine x? Like you use the derivative instead of just v?
Oh, okay. So you're talking about here, Ash, right there?
Yes.
Yeah, but once I get a new integral, remember what's going to happen? I'm going to go back to my checklist.
Mm-hmm.
Oh, do I recognize right? Do I recognize the antiderivative of cosine? Yes, sine.
Yeah.
Done.
Okay.
So we're kind of juggling a little bit. We got all these new methods, but inside these new methods, it's always going to revert back to an old method.
Okay, so
Right.
you took the antiderivative of v.
Exactly.
Okay.
So there's a couple of things that happen that are kind of cool in these problems. So there's just problem types. I'm talking. Let me do a new page here.
Sorry, can I ask a quick question?
Of course, Eleanor, go ahead.
This might be really obvious, but how did you get from the integral of x times sine of x dx to x cosine x, negative x cosine x?
Yes, so that's my uv. That's my uv, right? Minus the integral of v du. So u was x, and v was negative cosine. So I just plugged those in.
Oh, that's the I see.
Yeah. You'll get used to it. You'll get used to it. Just like we had to write. You all probably remember when you had to do quadratic formula. You had to write down the quadratic formula, and then you had to sub in and be careful of signs and all of that. It's just a more sophisticated.
But so right now with these problems, we're just trying to find like the right side of that formula.
Exactly.
Minus, okay.
Exactly. And of course, if I took the derivative of this, right? Of course, the derivative of the c is 0. But if I took that derivative, I would get back to x sine x. And that's what you want to make sure you try at least a couple of times when you're doing homework. Take your answer from by parts, integrate it, right? And I'm sorry, differentiate it and make sure you get back, right? Which will be a nice little review of product rule and quotient rule and all of that garbage. All right, so the problem types, that's what I want to talk about here. Let me do one more page so I get, there we go, problem types. So just a plain old IBP, integration by parts. Like we just did 2 of them. I will try and not make, sometimes you have to integrate by parts twice. And we're going to do one like that in a second. Lost my page. Stand by while we have technical difficulties. So problem types, just a plain old integration by parts where you should be able to solve the problem with one process, okay? And then it could be multiple by parts. I won't let it be more than twice, okay? So some problems could be 3 times you have to do by parts, 4 times you have to do by parts. I'll restrict it to 2 times. And I think I've already done that in the homework that I picked out for you in homework 2, which is 5.6, right? Step 3 could be what I call a loop, where you will see the original problem in your answer. So you'll see the left-hand side inside of the right-hand side, right? Eleanor, you were saying we're just trying to figure out that right-hand side. And so in this type of problem, you'll see the original problem inside of the right-hand side solution. And so in that case, right, I would see something like x equals a 2 minus x, right? What do you do in that? You're just solving for x, right? So it's simple algebra at that point. Where do I get x equals 1, right? So I move that x to the other side and divide by the coefficient, right? So 2x equals 2, right? So x equals 1, kind of thing. And then the fourth problem is, I call it a tic-tac-toe. It's a shortcut version to find by parts. And this can only be used when u to the nth derivative equals 0 eventually. And then I want to do the proof. That's not really a problem type. I just want to prove it to you, right? But the problem types are integration by parts. You might have to integrate by parts again. You could integrate by parts and then find the original problem back, and then we do a different process there. Or you could take the shortcut version, tic-tac-toe. On your test, I will say to you, use tic-tac-toe or use by parts. If I say to you, use by parts, and you can do tic-tac-toe, that's your option. But most likely, if I say to you, integrate by parts, you can't use tic-tac-toe. Okay? So I do like both of those to show up on your midterm. So we want to make sure we can do all of these. I usually don't do a loop. So let me do a loop first, okay? I guess I could do multiple times first, so let me do that, right? And these get a little nasty as you are doing problems with complicated insides. Now you have to be doing U subs and etc. It gets pretty nasty pretty fast, okay? So just be patient, be organized, right? Stay calm. If you make a mistake, you try the problem again. If you make another mistake, go make dinner for everyone and then send me an email and let me try and help you, okay? Don't spend hours and hours doing things wrong, please. You have more important things to do in your life, okay? So it's like if you're doing your taxes and you're confused about something, you're going to sit there and just think about what to do. Hell no, you're gonna click on the button where you could talk to somebody, right? I don't know if you're doing your taxes yet, but get help. Don't wing it when you're doing your taxes in the future, please. And you certainly don't want to make a mistake, right? So if you keep making mistakes, you're wasting your time. Get some help, all right? You can post it on the Discord, right? Ash, is there a way you can post pictures and things you could take on the Discord? It's just like a regular chat. You can post a picture and
do all that, pictures, videos, documents.
Yep. So you can put it up there and see if someone in the class has gotten success with it yet. You can send me an email anytime. I'm kind of old, so I do go to bed early, but I usually wake up at 6, so you could get an answer from me very early in the morning. If I'm awake, I'll try and answer right away. And it might be a quick answer from me. But then, of course, at the start of every class, I'll be doing problems, so I can do it then as well. All right, let's do a quick, how much time do I have? Oh, it's tight. I think I can do it. So let's do the integration by parts with a multiple by parts, okay? And then we'll do a loop, and then I'll teach you the shortcut. IBP twice. So let's do the integral of x squared e to the minus x dx. LIATE, right? So my last choice for the u sub is the exponential. Do I have something that can take it before that? Yes, I got it, the algebraic x squared. So u is going to be x squared. Du is 2x dx. V is the integral of e to the minus x dx. I need a u sub here. I feel like I'm going too fast, so tell me if I am.
Hey Robert, are you still recording this?
Yes. It just because I touched that left corner. Is that what you're looking at, Nima?
Yeah.
Yeah, because I touched that left corner, that little timer went away, but it's still recording. Recorder is recording. Thank you for checking that, though. Whenever I go to my menu, it hides that little recording signature thing. But it is still recording.
I'm confused why V is the integral.
So if you kind of remember, I said pick u from the ate, right?
Mm-hmm.
Then find du. That's the easy part, right?
Mm-hmm.
And then everything else is dv. So everything
But
else
this includes the integral.
Yes, but everything else meaning yes, and then I integrate, and so I get v is the integral of e to the minus x dx. And I think I was saying that slightly different at the first,
okay.
And I think this is proper or more proper to say that v is everything else, including the integral. So I need a u sub here, right? I need a negative. So I get v is the opposite of e to the negative x. Hopefully those u subs will be becoming quicker and quicker for you all as you do more problems, right? As it should have been a Calc 1 topic, but now maybe as you practice, you'll get pretty quick with those u subs. Okay, we're ready? Everybody okay? Anybody need a minute? We're almost done with class. I will stick around today for office hours, if you have them. I don't expect you to start having real serious questions until we do 5-7. And then, certainly chapter 6, you'll need me. You'll need me on chapter 6. So, but I don't care. Any kind of question, a quick question, a long question, right? Anything you need. My dog's asleep. Okay, so I've got the integral of x squared e to the minus, and I need the u, which is x squared. I need the dv, uv, so minus x squared e to the minus x, minus the integral of v du, so 2x dx, sorry. How are we doing there? Anybody there with me yet? No one's there with me yet? Charlie, thank you. Eleanor, great. Sarana, awesome. Angel, Peruse, Ashley.
Professor,
Yes, one.
One question.
Yes, sir.
The negative that we have in front of the x square,
Yes.
the negative.
Yes, right here.
Okay.
Yes.
That is because it's the negative from V, right?
Exactly. But then once I put things together, I try and write them in our logical order, which would be sine, coefficient. Yeah, exactly.
Oh, okay. Yeah. Just to be sure.
Yes. Well, you can see it's by parts again, right? You can see it's by parts again. So, I'm just going to repeat. So now u is 2x, and du is 2dx. V turns out to be the same thing, right? And this is what's going to happen usually. V is still that integral of e to the minus x dx. So that's negative e to the negative x. So now for the second integral here, for this green, right, I'm putting in a whole new, by parts. So a whole new uv minus the integral of v du, right? So uv is negative 2x e to the minus x minus the integral of 2 e to the minus x dx. And you can see it's going to, now it's back to a simple u sub, so it's not going to be by parts anymore. Okay, so we still got about 30 minutes left. Remember, if I end class early, well, one, I'm staying for office hours, right, till 11:30. Starting next week, I have advising hours after a class from 11:30 to 1:30. If office hours extend into that time, I'm okay with that. If you have questions that will, right, if 5 of you get there or stay for office hours, what I try to do in office hours is just ask a question, ask the next student a question, and just keep going around until everybody's questions are answered. If you need one-on-one time, you're going to schedule that with me, and then we'll meet. I can meet any day of the week. I usually am gone on Saturdays and Sundays. Just try and get outside and things like that. So I don't know if the weekend is great to meet for office hours, but I answer emails over the weekend. Okay. But if you feel like you need the one-on-one attention, and last semester I got to tell you, I offered my three classes. I had 2 Calc 2s and a Calc 1, and I offered every student a private one-on-one meeting, and only 3 students took me up on it. Only 3 students took me up on it. One of the students didn't show up for the final. Another student squeaked out a C, and the other student was an A student and didn't need to meet with me anyway. But I offered it. I offer it to my students that are not doing well, because I want you to succeed, right? But if you feel like you need that one-on-one attention, you'll schedule a time with me. I mean, you could come to office hours and you'd be the only one there, and then you get the one-on-one time, right? And that's fine. So anyway, next week I'll do if I can extend the office hours into advising hours, I will. If I have someone drop in for advising, I will either just ask you to wait or say we can meet another time. Right? Does that make sense? That I'm getting paid to be an advisor for math majors, by the way, from 1:30 to 11:30 to 1:30. And so if I get an advising drop-in, I need to take care of them first. But if you're willing to stick around, that would be fine with me too. All right, let's do a loop. And then I'll do the tic-tac-toe, and then I'll prove the theorem. If I don't prove the theorem, I'll do it next week. If I run out of time, it's not that important. It's only important for the math majors in here that you really see the proof. But it's quite a simple proof.
Professor?
Yes, Ashley.
Can you explain how you got from so the left side?
Yeah. So can I go? Yeah. Can I go numbers?
Yes.
Yes. So 1, 2, 3, 4, 5, 6, 7, 8, 9. I think 10 and 11. Right? Where are you?
So on 7, did you just take the Did you take the antiderivative or?
Okay. So 7 is here and here are the same. Yep. And then from here, this one. Oops, sorry. This one is the same as this one, right? And then I did the second by parts here.
Okay. I see how you did inside of 9. You just did the UV.
Exactly. This is the new UV minus the integral of V du. But this integral now is just a simple U sub. It's just a simple U sub. And I did it in my head. So from here to here, right? So 2 times the integral of e to the minus x dx is negative 2 times the integral of negative e to the negative x dx. There's my U sub. And then I get negative 2 e to the minus x. I kind of skipped all of that, right? Where u is negative x and du is negative 1 dx. So I have now negative 2 integral of e to the u du. Yeah, I skipped all of that piece.
Okay.
All right, let's do a loop, okay? And you'll see what I'm talking about. So I want to do the integral of e to the x sine of x dx. This one's going to give me a loop. And I'll probably say to you, do it as a loop. Okay? I don't usually give the loop or the multi... that's not true. I did give a multi integration by parts on the final last semester. So my Lyautey list is, I'm going to get a trig first, right? So u is the sine of x. Yes, you with me? So du, derivative of sine is cos, right? How we doing here? We okay? We happy it's almost over? I am. I want to eat lunch or breakfast. The rest of it is v, the integral of e to the x dx. Oh, that's nice. Thank you, Robert. V is just plain old e to the x. So I've got the original integral e to the x sine x dx. And slow me down if I'm going too fast. I need uv, so I need e to the x sine of x minus the integral of v du, e to the x cos of x. And I don't know if you can see it, but you can see I've just toggled from an e to the x sine of x to an e to the x cos of x, and guess what? I'm going to toggle again back to an e to the x sine x. And so that's when I see my problem, my original problem back in there again. So I need another by parts here, Don't let me go too fast. Is everybody with me? Anybody need a minute? Better question, does anybody need another minute? No problem, one. I'll wait.
Can you repeat that last step?
Yes, so the last thing I talked about, that toggle thing I said. So this is my uv minus the integral of v du, right? But I had said, notice I've gone from an e to the x sine x to an e to the x cos x. And guess what? It's going to switch back to an e to the x sine x next. And that's where I'm seeing the loop part.
Right. Okay.
Yes.
Thanks.
I mean, I see it because I've been teaching this for 20 years, and I studied it for, oh my God, 7 years. So I need another u sub. So u is cos of x now. Du is negative sine x. V is the integral of e to the x dx. So that's just e to the x. So in black is my original problem. And then in this parenthesis here in green is my new by parts. So it looks like I have e to the x cos x minus the integral of, oh, I forgot a dx somewhere right there. Sorry. Minus the integral of v du, so plus e to the x sine x dx. Don't let me rush, because the next two steps are key. So, but make sure you're with me here. Let me know if I can just delay the time a little bit.
Give me a second.
No problem.
So when we do a second u sub, we just do the uv minus the integral v du?
Yep.
Okay.
And you can see I tried to keep my original problem all in black here, right? And then this stuff is happening all inside of the box. There's my new by parts piece. So I'm going to distribute that negative, okay? Josh, okay?
Yeah.
Nice. So I'm going to distribute this negative, e to the x sine x, minus e to the x cos x, minus the integral of e to the x sine x dx. And that is the original problem. This is my loop part, where I'm seeing, oh, I'm back to the beginning again. And if you could see, so look, you can imagine if I do this by parts again, and then again, and then again, I'll just keep going around in a loop, right? We don't really want to do that. So I'm going to move that integral to the other side, and I'm going to get two of them on the right. Right? So I added that integral onto the left side. So I took that integral and moved it to the other side, right? So now I have two of them on the left. And now I'm going to divide by 2. And I can factor a little bit there, make it easier. Do I care about a constant over 2? Because no, it's just another constant. So I finally get the integral of e to the x sine x dx is e to the x over 2 times sine x minus cos x, all plus some constant c. And there's my final answer. so close. We're so close to being done. Only one more problem type and a proof. I think I'll just save the proof till next time. Right, I'll do the proof and then I'll do another example or something. Of course, you might have questions for me from the homework. There's a couple of nasty ones in WebAssign in this section, but there's a couple of easy ones too. And again, you know, do the MindTap problems. Oh, what do I like for MindTap on this one? I like 1 to 23. Oh, actually, I like 25 to 30. I like 1 to 30. 1 to 30 are nice. 25 to 30, you have to make a U sub inside first and then do by parts. So those are really cool. If you can do a couple of those, that would be good. So we said MindTap 1 to 30.
How did you divide by 2? Number 8.
Yeah, so when I have one of these, and then I move the negative one over, so now I have 2 of those. Right? So you see the positive integral of e to the x sine x, and then you see a negative integral of e to the x sine x. So I move the negative over to the other side, so I have 2 of them now. And then divide by the 2 to solve for the original integral. Does anybody have written down what I said for 5-5 for MindTap?
I think it was 1 through 57.
Yes, thank you. And this is homework 001. This is homework 002. In WebAssign, right? How are we doing? We're ready? We're ready for the easy version, the shortcut version.
Is the homework both odd and evens in the book?
Yeah, well, odds are there. The odds are there quickly, so you can see the answer quickly, right? If you have the physical textbook, the odd answers are in the back in the appendix, one of the appendices, okay? You can do even problems if you're crazy, and I'm not talking just to you, Josh, anyone. If you want to do even problems, you're probably a little bit wacky, but you can check your answers there on Symbolab, or you could check them by doing derivatives, right?
Okay.
Yeah,
Thanks.
and then so that's for you to really feel comfortable with things, and then of course what I'm giving you a homework grade on is the WebAssign.
Got it.
Yeah, nice. So there's a couple of aspects of things I want you to do. Redo the problems that we do in class, right? Rewrite your notes as if you're the teacher, right? You look at the problem and then do it and see if they match your notes. Do problems in the book. Read the sections in the book. Do the WebAssign problems. Do my old exams, right? I'm going to have several of them up there for you, right? So you don't want to leave that piece out. You want to make sure you do the old exams. Okay, let's do the coolest version of this. I call it tic-tac-toe. Of course, it's not my name for it, but just because I'm going to do tic-tac-toe. I'm going to, like 3 across, whatever this stupid game was. I don't remember. So, but the idea is I'm going to fill out a table of sine of u and of dv. And it's not ideal, the way I do it, but the sign always alternates between plus and minus. Oops. So always starts with plus, minus, okay? U goes in as U, and then U prime, and then U double prime, all the way till I get to 0. Remember, this shortcut only works if eventually my derivative of U is 0. Otherwise, it's a loop, or it's a multiple by parts. This only works if U eventually has an nth derivative that's 0. And once you get to the line where U is 0, it stops, right? So you're going to do derivatives of, start with U, and keep taking derivatives until U to the n is 0, right? The nth derivative. It's not like U squared. It's U to the triple prime, U to the fourth prime, U to the fifth prime, right? Nth derivative. And then here we're gonna integrate. So start with V. And keep integrating. And then our answer is going to come from tic-tac-toe. Kind of messy, but once you start practicing, it'll be very quick. If I say to you on the test, use tic-tac-toe, I want you to use tic-tac-toe. If I say to you, use integration by parts, and you can use tic-tac-toe, then feel free to. If I say to you, use integration by parts, and you can't use tic-tac-toe, then you have to use integration by parts, right? It saves a lot of time. Okay, so we'll do one more example today, and then we'll quit. Of course, I'll stick around. Okay. I just feel like even 3 hours with 2 10-minute breaks is a lot. Even I just take the last 10-minute break at the end. But of course, I'll stick around now. So I say class is over, and you might. So maybe you need to go grab something quick to eat, and then. But I'll be in my office hour till 11:30, so you can come back. Okay. Probably nice for you to say I'll be right back or something. You need a break, right? And then starting next week, I will be in my office hour till 1:30. It's really my advising, right? Your office hour would go to 11:30, and then my advising goes from 11:30 to 1:30. I'm probably in the kitchen washing dishes or whatever, doing laundry. I'm doing something, right? But when you come into the room, I can hear it, and then I come in. So just be patient with me if you come into the office hour. You'll see my picture up there, right? And you might start yelling for me, but I'll be there. If you come into a meeting that we're supposed to have together, or I'm supposed to be there, and I'm not there, so you'll be able to come into the room, but you'll be the only one there. Just send me a quick email, right? And say, where the hell are you, you bum? Okay, let's do this problem here. So we're doing the integral of x squared e to the x dx, right? Is that what we did last time? No, we did e to the minus x, right? And so clearly I pick u as x squared, and I notice that if I do a derivative, I get 2x. And I do a derivative again, I get a 2. And I do a derivative again, I get a 0. So this is a candidate for tic-tac-toe. And I know v is the integral of e to the minus x dx, right? So here we go. I have a sine, I have u, I have dv. And if you look this method up on the web, other people do it different ways. This is just the way that I've gotten myself to think it's a little bit easier. So I start with u is x squared and then derivatives until I get to 0. And then dv, I've got to integrate this to get v, right? That's minus e to the minus x. And if you can see, I'm going to keep getting a negative out front. So I get an e to the minus x and then another e to the negative e to this. And I don't care about this last row. Once I get to a 0, I don't need that row anymore. Because remember, I'm going to go tic-tac-toe, right? I'm going to go tic-tac-toe, and the one that I go across in 0 goes away anyway. How are we doing here? I know it probably seems strange, but so I get negative e to the negative x squared. There's my tic. My tac is negative 2x e to the minus x. And the last one is negative 2 e to the minus x. And then I add a constant c. And then I can, of course, factor out. And I get the same answer as before. Oh my God, so much quicker. So much quicker. And one of the things, go ahead, Eleanor.
You go across those last 3 lines.
Exactly. Multiply, add, multiply the row, add it, multiply the row, add it. Yep.
Okay. And you always just do the last 3 before 0?
Well, up until you get to the 0 row. When you multiply that row with the 0 in it, it goes away.
Right. Uh-huh.
Right.
But so it's always 3
No,
lines.
it's not always 3. Could be less, could be more.
Oh, okay.
It depends on how many derivatives it takes for u to get to 0. Right? If I started with x, so u is x, derivative is 1, derivative is, again, is 0. So that's only 2 rows. Right? If I started with x cubed, I get an x cubed, then a 3x squared, then a 6x, then a 6, then a 0. Right? So,
and so if you have 5 lines,
exactly.
you just use all.
Exactly. Yeah. Let things happen, right? As we learn these processes, let things happen and be your creative mathematical selves, right? So reassess. Okay, can I do this? Do I know how to do this? Do I have to do something else? Right? So let things happen as you do them. Don't feel like it has to be a certain way, right?
Okay, so essentially based upon I think I get it. So based upon the chart, we're just taking the derivatives of u and the derivative
Antiderivative of v, yep, of dv.
Of dv. So, okay, never mind. I get it. Yeah.
Yeah, and it's usually that last row, that last column where students will forget to take the antiderivative first. And it's weird, I guess it's weird the way I have it set up, right? I say start with u in the first row and then keep taking derivatives. But in the first row, I say first find v and then keep taking antiderivatives. And I just did it that way so that I would get the rows just multiply right across to get the solution. So, but other people do it another way. You don't have to do it the way I do it. You can go find a nerd on YouTube, another nerd on YouTube, and follow their process.
I got a quick question.
Yes, Caleb.
Does the sign always start positive? Or does
Yes,
it depend
always starts positive.
Okay.
Because if you think about it, if you see what am I really getting from this first piece is I'm getting UV. So I'm getting UV. And then what am I getting from the second piece? Minus the integral of v du. So I'm always starting with positive UV minus integral v du. And then rinse and repeat. You get another plus UV minus of v du. And so that's why it's going plus, minus, plus, minus, plus, minus.
All right.
Does this always work?
Only when the nth derivative of u is 0. So,
right.
So tic-tac-toe, right? So if I looked at that first one, ln of x dx, u is ln, u prime is 1 over x, u double prime is 1 over x squared. It's never going to go to 0. So tic-tac-toe wouldn't work there. So I need my u. So pretty much you can tell. Look, if u is a trig, is the derivative ever going to go to 0? No. If u is an exponential, is the derivative ever going to go to 0? No. So the only time the derivative is going to go to 0 is when it's algebraic. When your u sub is algebraic, right? And then the trick there is, like if I gave you x ln of x dx. All right, you say, oh, it must be a tic-tac-toe because there's an x there. But if you remember your Leonte list, right, your first choice for u is the ln. So you can't use tic-tac-toe there, right? Because so now v is the integral of x dx, right? So you just have to, you've got a formula sheet. You're going to put it in as much detail as you can. You're going to practice. And you're eventually going to say, oh, I don't need that on the formula sheet. I got this part, right? It's a good idea to try and keep as much on as you can because some people get nervous during a test and blank out a little bit, right? And so you've got that formula sheet there to give you, a way for you to assure yourself that you're doing something correctly. And if anyone else asks you, no, I don't give a formula sheet. Oh, I recorded that, so there it's official. I don't give a formula sheet. All right, I'm done for today. Perfect. 9 minutes left. Let's take our last 10-minute break at the end of class. I'll stick around for questions. Right? You got enough to do. You got homework 1 and homework 2 to do. I would like you to read 5, 6. You got some mind tap problems to do. I don't really want you looking at that midterm yet. It's a little bit frightening. Okay? So don't worry about that yet. I posted it, but don't bother with it yet. You got those review problems from 5, 5. You can do all of those. Again, don't do the application problems in that. Only do the integration and don't do the area problems, right? Only those integration methods. I think they're inverse trigs, and then there's u subs, and then there's change of variable, a bunch like that. So, all right. So good. What is today? Wednesday? So tomorrow's our last class for the week. Thank God, right? We'll probably do 5, 7 tomorrow. I don't know if I'll get all of it because there's about 4 different methods. Whereas today we did 1 method with 4 different problem types. Next class is 4 different methods and a bunch of different problem types. So, it's a longer section. But I know we've got time to do it. I'm not in a rush. We'll get everything done. And it's just up to you to practice a little bit every day. I can imagine today you could easily do a few hours of work. You want to pace yourself. You can take some of those hours from Monday, Tuesday, Wednesday, Thursday and move them to Friday, Saturday, Sunday, right? You got to make sure you stay sane, though. Make sure you're you're not sitting there for hours in a row, right? Just chip away, ask questions, send me an email. Okay. Anything for me before you all go? All right. Have a great day.
Thank you.
Thank you.
Thank you, Professor.
You got it.
Professor.
Thank you.
You got it.
Professor.